Sci-Fi presents 5 facts about black holes. Number 1. Massive star collapsing in upon itself. A black hole is formed when a large star starts running out of fuel and begins to collapse under its own gravity. Such a star may become a white dwarf or a neutron star. But if the star is sufficiently massive, then it may continue shrinking eventually to the size of a tiny atom, known as a gravitational singularity. A black hole refers to the region in space in which the singularity's gravitational force is so strong that not even light can escape its pull. Number 2. Physical laws cease to be valid at its core. The singularity at the core of a black hole may shrink to a size smaller than an atom, and eventually become an infinitely small point in space containing infinite mass. Here the gravitational force is so strong that the spacetime surrounding the singularity is bent to infinite curvature. And scientists are left searching for a good quantum theory of gravity to explain what is truly going on inside these incredibly dense objects. As American theoretical physicist Kip Thorne overstates in his description of a singularity, it is a point where all laws of physics break down. Number 3. Black holes distort space-time. The mass of a black hole is so dense and the gravity of its singularity so strong that, in accordance with Einstein's theory of general relativity, it actually distorts the space-time around it and not even light can escape. The boundary beyond which light cannot escape the black hole's gravity well is known as the event horizon, while its radius is called the Schwarzschild radius. Once particles and light rays go past the event horizon, the light cones tip over and point to the singularity, which now represents all future directed paths with no escape possible. Number 4. Objects appear to freeze near a black hole. To an outside observer with a telescope, an object passing the event horizon will appear to slow down, then freeze in time without ever seeming to pass through the event horizon. This is because the light takes longer to escape the black hole's gravitational pull and light signals won't reach the viewer for an infinitely long time. As time elapses, the light subsequently becomes red-shifted and dimmer as its wavelength becomes longer, eventually disappearing from the sight of the observer as it becomes infrared radiation, then radio waves. Number 5. A person falling into a black hole would be spaghettified. If a person was able to survive long enough to describe falling into a black hole, he would at first experience weightless as he goes into free fall, but then feel intense, tidal, gravitational forces as he got closer to the center of the black hole. In other words, if his feet were closer to the center than his head, then they would feel a stronger pull until he eventually is stretched and then ripped apart. As he falls in, he may observe distorted images as the light bends around him, and he will also still be able to see beyond the black hole as light continues to reach him from the outside.